The cosmos is a grand stage filled with wonders beyond imagination. Every night as we look up at the stars, we're gazing into a vast expanse that has inspired humanity for millennia. The universe is not just a backdrop for our existence, it's a living, breathing mystery, waiting to be unraveled. But what if I told you that everything we see, every star, planet, and galaxy, is just a tiny fraction of what's really out there? The visible universe is only the tip of the cosmic iceberg, a mere sliver of a much grander reality that remains hidden from our eyes. Imagine standing under a single street lamp in a vast, bustling city, the rest hidden in darkness. That one pool of light is all we can see, while the true scale and complexity of the city stretches far beyond, shrouded in shadow. That's our universe. Ordinary matter is the street lamp, but a much larger, invisible city of dark matter surrounds us. This mysterious substance doesn't emit light or energy, yet its gravitational pull shapes galaxies and holds the cosmos together. This is one of science's greatest mysteries, a cosmic detective story that has captivated generations of astronomers and physicists. The search for answers has become a quest to understand the very fabric of reality. The clues are scattered across the heavens, written in the light of distant stars and the motions of galaxies. Every flicker, every shift in the night sky is a potential piece of the puzzle, waiting to be decoded. For decades, scientists have searched for answers, and now, a bold idea is emerging. The possibility of a fifth fundamental force of nature. This force could be the missing link, the key to unlocking the secrets of dark matter and the unseen universe. If true, it would revolutionize our understanding of the universe, revealing a hidden side to reality. It would mean that the laws of physics as we know them are just part of a much deeper, richer tapestry. The hunt is on, with brilliant minds using everything from giant telescopes that scan the farthest reaches of space, to tiny atoms in their labs, searching for the faintest hints of this new force. Every experiment, every observation, brings us one step closer to the truth. Join me as we step into the shoes of these cosmic detectives, examine the evidence, and explore the tantalizing possibility of a new force. Together, we'll follow the trail of clues, from the smallest particles to the largest structures in the universe. This is a story about the universe, and about our relentless curiosity to uncover its secrets. It's a journey that connects us all, driven by the desire to know what lies beyond the visible, to push the boundaries of human knowledge. The universe is whispering, and we're learning how to listen. With every new discovery, we peel back another layer of the cosmic mystery, bringing us closer to understanding the true nature of reality. What is dark matter? It's one of the most profound mysteries in all of science, a puzzle that has captivated astronomers and physicists for decades. When we look out into the universe, we see stars, planets, and galaxies, but there's something else out there, something we can't see directly. Simply put, we don't know what dark matter is. Despite years of searching, its true identity remains elusive. Scientists have proposed many theories, but so far none have been proven. But we know it's there. The evidence is overwhelming, even if the matter itself is invisible to our eyes and instruments. We can't see or touch dark matter, but we can observe its powerful gravitational effects. Stars and galaxies move in ways that simply can't be explained by the matter we can see alone. In the 1970s, astronomer Vera Rubin made a groundbreaking discovery. She found that stars at the edges of galaxies were moving much faster than expected. This was clear evidence for a massive, invisible halo of matter surrounding each galaxy, something that couldn't be explained by ordinary matter. This mysterious, missing matter is what we now call dark matter. It's everywhere, yet completely undetectable by traditional means. We also see dark matter's presence through a phenomenon called gravitational lensing. When light from distant galaxies passes near a massive object, it bends more than it should if only visible matter were present. This extra bending is caused by dark matter's gravity. Calculations and computer simulations show there's far more mass in the universe than we can see. Dark matter is the hidden culprit, shaping the cosmos on the largest scales. Ordinary matter, the stuff that makes up stars, planets, and us, accounts for just 5% of the universe. Dark matter makes up about 27%, a staggering amount compared to what we can see. The rest, about 68%, is something even stranger: dark energy, a force driving the universe's expansion and an even deeper mystery than dark matter. Without dark matter, galaxies as we know them wouldn't exist. After the Big Bang, there wouldn't have been enough gravity to pull matter together and form the cosmic structures we see today. Dark matter acts as the invisible scaffolding of the cosmos, connecting galaxies in a vast cosmic web and holding the universe together. Its existence is fundamental to our understanding of how the universe works, from the smallest galaxies to the largest clusters. Yet, despite all we've learned, the true nature of dark matter remains one of science's greatest unsolved puzzles. What is it made of? Where did it come from? The answers are still out there. The search for answers continues, as scientists around the world use ever more powerful telescopes and experiments, hoping to finally shed light on the universe's missing matter. To grasp why a fifth force would be revolutionary, let's meet the four we know. Gravity holds planets, stars, and galaxies together, weak on small scales but dominant across the cosmos. Electromagnetism powers light, electricity, and magnetism, binding atoms and shaping our daily lives. The strong nuclear force glues quarks into protons and neutrons, and holds atomic nuclei together. The weak nuclear force drives radioactive decay and powers the sun. These four forces form the foundation of the Standard Model of particle physics. But here's the catch: the Standard Model can't explain dark matter. Dark matter doesn't interact with light or electromagnetism. It's invisible to all but gravity. That's why the idea of a fifth force is so compelling. It could be the missing link. The search is on for a new force that connects the visible and invisible universes. The Standard Model's failure to explain dark matter has sparked a search for something new, a possible fifth force. For decades, physicists have relied on the Standard Model to describe the universe's fundamental particles and the four known forces: gravity, electromagnetism, and the strong and weak nuclear forces. Yet the mysterious dark matter, which makes up most of the universe's mass, remains invisible and unexplained by these forces. What if dark matter isn't just silent, but has its own interactions, perhaps even a force that bridges its world and ours? Imagine a hidden connection, a subtle influence that shapes galaxies and cosmic structures, quietly weaving through the fabric of space. Scientists are designing experiments to listen for this faint whisper. They're pushing the boundaries of technology, building ultra-sensitive detectors and refining their methods to catch even the slightest hint of something new. One approach: measuring tiny anomalies in how electrons orbit different isotopes of atoms like calcium. By comparing these orbits with extreme precision, researchers hope to spot deviations that could signal a new force at play. If a new force exists, it could cause subtle, measurable differences. These differences might be so small that only the most advanced instruments can detect them, but their implications would be enormous. Another strategy: tracking the orbits of asteroids or satellites for deviations from gravity's predictions. Even a tiny, unexplained shift in their paths could hint at the influence of an unknown force. Even the tiniest ripple could signal a new force at work. Just as gravitational waves were once only a theory, these faint signals could open a new chapter in physics. Atomic spectroscopy, using lasers to measure energy shifts, could also reveal its presence. By analyzing how atoms absorb and emit light, scientists can search for patterns that defy current understanding. The goal: find a consistent pattern of anomalies that can't be explained by the four known forces. Only through careful analysis and repeated experiments can scientists be sure they've found something truly new. Such a discovery would be the smoking gun for a new force of nature. It would revolutionize our understanding of the universe, opening doors to mysteries we can only begin to imagine. The search for a fifth force isn't new. History is full of intriguing hints and false alarms. In the 1980s, a proposed repulsive fifth force faded after experiments failed to confirm it. More recently, a Hungarian team reported an anomaly in beryllium and helium decays, hinting at a new particle, the X-17 boson. If real, X-17 would imply a new force, but no other experiment has confirmed it. These stories highlight the importance of skepticism and replication in science. Strange results can arise from errors or statistical flukes. Every dead end teaches us to build better experiments and refine our theories. The hunt continues, each step bringing us closer to the truth. Where do we stand today? As of now, a fifth force remains unconfirmed. We have hints and anomalies but no definitive proof. The calcium isotope results are preliminary. The X-17 anomaly remains unresolved. Astronomical searches for orbital deviations are ongoing, but evidence is still circumstantial. The Large Hadron Collider found the Higgs boson but not dark matter. This has pushed scientists to explore new ideas, like a weak, elusive fifth force. We've ruled out many simple explanations, narrowing the search. The anomalies we see guide our next steps. The scientific community is buzzing with new experiments and debate. The truth is still out there waiting to be found. Why is today's search for a fifth force different? The answer: new ideas and new technology. Instead of smashing particles together, scientists now use ultra-precise measurements, like atomic spectroscopy and isotope studies. Our tools are so sensitive, they can detect deviations as small as 1 part in a quintillion. Theoretical advances suggest a dark sector, a hidden world of particles and forces. A fifth force could be the bridge between our world and this dark sector. Today's search is also broader. Atomic physicists, nuclear physicists, and astronomers are all looking for clues. If multiple experiments find consistent evidence, the case becomes compelling. This cross-confirmation is what makes the current era so exciting. We're closer than ever to uncovering new physics. The next breakthrough could come from anywhere. The next chapter in this search is unfolding now. Teams are refining their measurements of calcium isotopes and testing other atoms for similar anomalies. New telescopes like the Vera Rubin Observatory will track billions of objects, searching for subtle effects of a new force. Missions like Gaia will map stars with unprecedented precision, testing gravity on galactic scales. The X-17 particle is inspiring new experiments worldwide, either to confirm it or rule it out. Every result, positive or negative, moves us forward. Progress comes from global collaboration, physicists, astronomers, and engineers working together. The answer could come from a lab bench, a telescope, or a particle accelerator. We don't know where the breakthrough will happen, but we'll keep searching. The next discovery could be just around the corner. When we look at the night sky, we're staring at the frontier of human knowledge. The search for dark matter and a fifth force is driven by our boundless curiosity. We ask, what is this place? How does it work? This quest connects us to generations of explorers and dreamers. At its heart is a balance between hope and skepticism. We must imagine new possibilities, but also demand rigorous evidence. Confirming a fifth force would transform our understanding of reality, opening a new universe of particles and interactions. Even if current hints lead nowhere, the search itself is a victory. Every experiment deepens our knowledge and sharpens our tools. The universe owes us no answers, but we'll never stop seeking them. The journey is the destination. As we probe the darkness, we do so with humility, rigor, and wonder.